Hi, I'm George Fraser. I'm CEO and co-founder of Fivetran, and I'm joined today by Justin Borgman, CEO of Starburst. Thanks for being with me, Justin.
Great to be here, George.
So Starburst is the premier commercializer of Trino, the query engine. Justin, tell me a little bit more about Starburst. What does Starburst do? How do Starburst and Fivetran work together?
Sure. Yeah. So we're about 6.5 years old as a company, but the technology really was born at Facebook almost a little over 10 years ago, in fact. And as you mentioned, it's a query engine, allows you to run SQL analytics on data that lives in a lake, as well as being able to federate other data sources as well. I'm sure we'll get into that in this podcast at some point. And one of the nice things about Trino and therefore Starburst is we see a ton of customers choosing to build essentially a lakehouse or a data lake based warehouse leveraging open formats, where rather than loading that data into a traditional data warehouse, they choose to store it in open formats like Parquet files or some of the more modern formats like Iceberg and query that data there. And the result of that can be a much lower cost data warehousing solution, and one that doesn't have any of the lock-in associated with traditional data warehouses. And so to answer your question about Fivetran and Starburst, I think one of the great ways that we can work together, especially with some of your more recent support of data lakes, is that ingest into S3, into open file formats, is something that customers need just as much as they do if they're running a cloud data warehouse, right? Being able to access the many different data sources that you support and run through that process of ingesting that into the lake is a great way to build essentially a lake house, if you will.
That makes a lot of sense. I suspect we're going to talk a lot about Iceberg today. Iceberg has really changed the game of data lakes and is really the key to the fact that Fivetran and Starburst can now work together. Fivetran can ingest data into an Iceberg data lake that Starburst can read. I suspect that historically, most Starburst customers were probably reading data lakes that they had constructed themselves by employing data engineering teams that wrote code. Is that fair?
That's exactly right. The early adopters were very much do-it-yourselfers who, you're exactly right, were building lake houses before they were called lake houses and building their own ingest pipelines into, Parquet files or early adopters of Iceberg and managing that themselves. And for us, at least, the opportunity we see as Starburst is to help make that process easier, to help manage some of those components that might be challenging for somebody who does not have 50 people on their data engineering team, who isn't Facebook, for example.
Yeah. We say at Fivetran that our mission is to make access to data as simple and reliable as electricity. And our goal is to make the problem of centralizing data as easy as plugging into the socket, into the wall. And the cool thing about Iceberg is it allows us to interconnect with the whole open source community, including query engines like Iceberg. So that's I think what makes it so exciting. Data lakes are becoming more accessible. They're becoming finally more mainstream. You don't have to have a huge engineering team in order to build a data lake. You can leverage tools like Fivetran and Starburst to put it together, even if you don't have the resources of Facebook. So there's a lot of query engines out there. What makes Starburst different?
Yeah, well, first of all, I guess going back to its origins, it was born at the largest scale imaginable, right? It had to be able to handle Facebook's query volumes and the sheer volume of data, hundreds of petabytes of data. And so that's one element, is that this is proven at scale. It's used by some of the largest hyperscalers in the world, Apple, LinkedIn, Netflix, Airbnb, Lyft, you name it. So proven at scale is one component of it. Another piece of it is strictly performance itself. It's highly tuned, highly optimized, and delivers incredible performance. And I think to your point about lakes becoming maybe a little bit more mainstream today, I think performance has a lot to do with it, right? Like the first lake was Hadoop 15 years ago. And a lot of these concepts were really pioneered back then, but the performance was lacking. And so Hadoop was not really able to be a completely suitable alternative to, let's say, a Teradata, where I used to work actually. And so today that is no longer true. Like the gap has closed. And these query engines are incredibly fast. And so that's another calling card. And then I'd say the third piece of it is this notion of it being a truly disaggregated stack, meaning that you can query any data source Lakes tend to be a large center of gravity, and we think they should be for the goal of managing your cost of ownership, and open formats are great. And so we'd say put as much data in Iceberg as you possibly can. But there's also value to being able to federate a query across two different data sources and join two tables that live in two systems and go direct to source. And what's interesting about Trino is it does both really well.
Mm-hmm. What are some examples of federated sources that customers are leveraging with Starburst or with Trino more broadly today? Like if I'm federating between Iceberg and something else, what might that something else be?
Yeah. So some of the most popular are other single node databases that are analytical data marts or at some level in an organization's data architecture. So a MySQL database, a Postgres database, for example, RDS on AWS. That's a very common use case. Another common use case is to connect actually a classical data warehouse like a Redshift or a Snowflake with data sitting in Iceberg in your lake and being able to join between those two. Because what we find is that even those who have largely centralized in a cloud data warehouse, they most likely have a lake as well with some data sitting there, because it becomes more cost prohibitive to truly store everything you have in a cloud data warehouse. And so very often people have both. And so being able to federate between those two. And then there are also, I would say, maybe more innovative use cases where you're querying a Kafka topic or you're querying a NoSQL database like Mongo. And again, joining that with something that lives in the lake.
Yeah, I will confess to being a query federation skeptic. My perspective on this is that query federation works in two situations. One situation is when you have very high bandwidth from the source, like a data lake. And the other situation is demos. Query federation works great in demos because you can just write a query with a very selective predicate where account ID equals something, and that will get pushed down in the data source and it will work beautifully. And then when you run your real query, it'll be like, come back tomorrow after I successfully page through the entire account object of your Salesforce instance or whatever it is. I think the examples you gave, like querying operational databases like Postgres or MySQL or something like that, they're kind of on the borderline. It all depends on how much bandwidth does a Postgres database have to offer a federated query engine like Trino. It depends. It depends how much data is in that database, and it depends how much other load is on that database, because you're going to drive a lot of I/O when you execute that federated query against that database. But if the table is small, if it's a very small table that you're querying, that you're joining with something somewhere else, or if you just have a very selective predicate that's getting pushed down, okay, that can work. So that one's kind of on the edge. But in general, my perspective on this is, I think most people with these sources are going to end up doing change data capture into their data lake simply because they don't want to put that I/O on their production database. And once the data sizes get large enough and the predicate pushdown trick doesn't work, which it doesn't work for many queries, it's just going to become untenable. And so they're going to say, I need to make a copy of this data. Now, Fivetran is in the data replication business, so I suppose I'm biased, but I feel confident about this, that query federation, other than federating two lakes, is always going to be kind of niche because the sources, they just don't have enough I/O. Do you want to argue with me?
Partially. So let me start with where we agree. I think you're absolutely right that bandwidth can be a constraint. And it's a constraint that we, from the Starburst Trino side, have no control over. So you're absolutely right. That's an important consideration. I also agree, and this is maybe the part I agree the most with, is the it depends part. And I think maybe one other factor in the it depends is really the use case itself. I think there are great exploratory use cases, for example, where you are really just trying to answer an exploratory question, not necessarily generating a report or serving up a dashboard or something that you're going to do all the time, but rather this is like a one-off question of your data and it lives in 3 different places. And you don't want to have to go through the effort of creating new pipelines to move that data just to answer this one exploratory question. I think that's a great example where federation is useful. And there may be a performance sacrifice that you alluded to, but for the purposes of that exploration, that might be totally okay. And so the way that we approach this with customers is we actually lead with it depends. And we would say there are use cases for both. For performance and controlling your performance SLA, we'd say, yeah, put as much of that as you can in Iceberg. And I think that's where you and I completely agree. You want to do that for your dashboards, for your BI, for your reporting, for building data-driven applications. Actually, a lot of our customers build data apps on top of Starburst as well. You want to control those SLAs. But there are also, use cases where you want to go direct to source because your question is exploratory, because maybe the freshness of the data matters to some degree, like a Kafka topic example. And in some cases, it's the agility of iterating on a data application that you're building, and you want to sort of try out new patterns and new queries. I think the other thing that surprises people and might even surprise you, George, is that the federation is faster than people expect it to be, because I think the reference point is traditional data virtualization vendors, like the data virtualization vendors of, a decade plus ago that had to push down everything. And in this case, part of the beauty of Trino is it is a MPP architecture. It's a massively parallel processing architecture. So that parallelism allows Trino to do joins in memory. And especially if you're doing complex joins of tables across different data sources, it's doing a lot of that in memory and can actually execute that query faster than people might expect. So anyways, I'll just wrap by saying, I think it depends. I think we agree. And then maybe we also disagree at the same time.
I think Federation, the thing that is great about it is it has a great user experience. You can get wired in really quickly. The latency is not zero, because when you run a query against a SQL database, you're running against a snapshot of some point in the past. It might be 10 milliseconds ago, but it's not zero. I always hate it when people say things have zero latency. I'm like, that's not how physics works. Okay. There's always something, and it's probably longer than you think, but it has a great user experience. And I sometimes describe Fivetran as what we try to do is create the user experience of a federated system. But the implementational details are that we move the data. So we do mirroring. We create an exact replica of all of your sources in your data lake. And that feels like you're querying them directly. We're always trying to drive the latency lower. We can do 1 minute pretty reliably now, but there's no end. There's no finish line there. Like, we're going to keep making it lower and lower every year. So we can also agree that Query Federation has a great user experience. Okay, moving on to other subjects. Trino is at its heart, it's a query engine. There is a little bit of a renaissance going on in query engines right now. Kind of surprisingly, there's a lot of new ones over the last few years. So Databricks created Photon, which is a complete rewrite of their SQL query execution engine. Facebook created Velox as a rewrite of the query engine inside Presto, which is like Trino's cousin. They both descend from the same parent. I guess they're siblings. Trino and Presto. DuckDB has been getting a lot of adoption lately. We actually use it at Fivetran in part of our data lake implementation to rewrite the data. And there's more emerging ones like Polars and lots of others. What's going on here? Why are there all these new query engines coming up these days?
I think it all goes back to something that you mentioned towards the beginning of the podcast, which is that the lake is getting a lot of attention these days, particularly as a really low cost place to store data. And cost is king when it comes to the ever increasing volumes of data that customers are wrestling with. And this even has a tie-in to AI, which is of course the topic du jour. Like, as you're preparing for your AI projects, thinking from the standpoint of the resources that I have to bring to bear, how much of this is going to cost me, the efficiency with which I'm doing all of the preceding data management and data analytics steps before I even get to the AI piece of things becomes increasingly important. So I think that's all driving a lot of focus on data lakes, and hence a lot of interest in better query engines to basically produce a data warehouse experience on a data lake. And that was really the purpose of the creation of Trino in the first place, was to do exactly that. That's also been Starburst's mission, like really to provide a data warehouse experience on a data lake. And by experience, I mean the performance and functionality that you would expect from a traditional data warehouse. So I think, like Databricks recognizes there's a tremendous amount of money in that market. Certainly we recognize that as well. And I think that's where we're all looking to sort of challenge the cloud data warehouses with an alternative approach.
Data lakes are a very interesting enabler of innovation in query engines. If you have a data lake, it is a very low risk thing to do. to try out a new query engine. It's a two-way door. You can go back to your old one or to a different one. There's very little friction because everyone shares the same storage engine. And that is a really interesting development, I think, for the industry. And data lakes have been around for a long time, but as I said earlier, I think they're finally becoming more mainstream. They're becoming more accessible to the average company because, not to toot our own horns here, but because vendors like us are all wiring into this common format of Iceberg. So we've mentioned Iceberg a bunch of times here. For those who somehow are listening to this but don't know about it, what the heck is Iceberg and why is it so important?
Well, it's basically a layer on top of a Parquet file from a technical perspective. But the reason it's important is what it's adding is the missing pieces on the functionality side of a data warehouse in the lake. And by that, I'm referring to things like updates and deletes. Historically, in a data lake, if you're working with Parquet files, things were append only. Like you just keep appending. And that prohibited certain types of use cases. Like the most classic example is a GDPR use case where because of GDPR, you need to remove somebody from a table because they've opted out of your marketing database, right? And in a classical data lake setup, that was extremely hard to do. You had to sort of like reverse engineer that result. But now with a modern format like Iceberg, you can just go delete that row, delete George Fraser, or update George Fraser. Do not send George Fraser any mail. So that's what it's allowing. I mean, at Teradata, we would call this active data warehousing, being able to actually modify, update, and delete your data. It's not a transactional database. I don't want to set the wrong expectations. You'd still have an OLTP system for your transactional database, but you can do this level of transactionality for analytical purposes. And that's super exciting. It sort of closes the last mile on that distinction between data lake and data warehouse. And that's a big deal. It also enables things like time travel, which is cool. Being able to see your data change over time. And there's a lot of interesting functionality you now have with this modern format. And because it was developed at Netflix, so Trino has its origins at Facebook, as we talked about. Netflix was where Iceberg began. In fact, actually, Iceberg began originally to be queried by Presto and Trino. They're a big Trino shop today. And the idea there was to actually start to replace their traditional data warehousing workloads and move them to Iceberg and create this now, data warehouse alternative. So I think that's one of the reasons it's super exciting and gaining a ton of momentum in the market.
You said the word transaction there. And to me, that's really the crux of what Iceberg is. It allows you to perform transactions on a data lake. Part of that means the ability to do deletes, but it also means to do the deletes and inserts and updates and then have them all happen at once. And that's critical. It really fills the gap between data lakes and traditional database management systems like data warehouses. And it was crucial for Fivetran to be able to support data lakes that Iceberg come into existence. We didn't have the ability to write to data lakes as a destination for many years because of our model. Our model is mirroring. We create a mirror image of all of your systems of record, whether those systems are database management systems or applications like Salesforce or event brokers like PubSub. No matter what it is, we create a mirror of that data in your central data platform. And you couldn't do that with traditional data lakes because we didn't have this ability to edit and to edit in a transaction. And Iceberg gave us that. There were still many more hard problems that we had to solve in order to make it work. But Iceberg was a key enabling technology.
Yeah. And I would just say, one of the things that's very exciting and one of the reasons I'm enjoying this podcast with you today is it allows us to partner together much more effectively. This opens up a whole new frontier. And I think you have absolutely moved to where the puck is going. And we're super excited to work with you.
As are we. One of the things we wonder about with these data lake implementations that customers are doing now is to what degree are customers going to write back to this data lake? Is this data lake mostly going to be a read-only data repository for them? And to the extent that they're running queries and writing outputs to places, that's going to be somewhere else? Or is the data lake going to be read-write? What's going on today with Starburst customers? Are people commonly writing back to the data lake?
Yeah, they are, both in terms of leveraging Iceberg tables and doing updates and deletes, but also in their own ETL processes, or the T part of your ETL process, I guess, running a transformation and landing that new refined data also in the lake. I think historically, and this goes back to maybe some of our earlier conversation, historically, that might have been where the lake's job ended, and you might land that transform data into a traditional data warehouse. But I think increasingly, because these query engines are able to provide incredible performance now, that last step is no longer necessary, which means that the amount of data you may put into your cloud data warehouse may actually decline over time. I mean, certainly we have a vested interest in probably saying that ourselves, but I think that's likely true because, again, I think cost and flexibility and the openness that open formats provide.
If a customer is using a data lake and they're using Trino as a query engine, but they're also using other query engines, there is a challenge right now. If you want all the engines to be able to read and write the same data lake, that right part is a little complicated, trying to set it up so that people can read each other's writes, because there's a metastore layer in these data lakes. Iceberg is not the end of the story. There's one more layer that basically keeps a pointer to the latest version of every table. And there's a lot of different metastores floating around right now. And it makes it hard to get these systems. It's still a little bit difficult. If all the systems are just reading from a common data lake, that works great. That's working great today. However, if you want them all to be reading and writing and to be able to read each other's writes, that's where things are still a little bit woolly. It's still getting worked out how that's going to work. There's multiple visions of how that problem is going to be solved. How do you see that problem today?
Yeah. So first of all, I agree that that is a problem, and it is the right place to focus if you're watching this industry and wondering where do things settle out. Maybe to take one step back, I'll say that I think there has been maybe for the past year or two a battle at the format layer, because you have Iceberg, but you also have Delta from the Databricks folks. You have Hootie, which came out of Uber. So there are multiple formats there. It is becoming clear now today that Iceberg is going to be the winner there. I think that's becoming increasingly clear, but there was fragmentation there too. And I guess my point in bringing that up is I think we're now just at an earlier point in that same settlement that needs to take place at the metadata or the catalog layer that you're pointing to. Databricks has their own catalog. We have a catalog. It's called Gravity. Everybody has a catalog, basically. AWS has Glue. There's, of course, still the Hive Metastore, which is still widely used, believe it or not. So you've got a lot of options, and it's too early to say, frankly, who's the winner at that layer. And so I think as a result, some of us, at least Starburst, we're trying to support other people's catalogs. So, if you've got data in Snowflake, we'll be able to access that. If you've got data in the Glue Metastore, we've supported that one for years just because of the prevalence of AWS. The Hive Metastore we support. So that's been our approach, is to sort of like attack the problem by providing optionality to the customer. But there's no doubt that the dust has definitely not settled at that layer. And it may be another couple of years to see which catalog wins out. And there are even open source independent companies, built around this catalog layer as well.
All right. Last topic, AI. Every podcast today has to talk about AI. What is the relationship between Starburst and AI workloads? Are they siblings? Is Starburst feeding the AI workload? How do they sit next to each other in a typical customer?
Yeah, we're primarily providing access to the data that they need. And of course, I think the frontier that we're at in this AI world from a commercial perspective is that customers now want to leverage their own data and either create their own models or enrich their own models, leveraging their own proprietary data. Sort of like GPT was like the public demo, for everybody to try out the concepts. And now they want to make it real and find competitive advantage. And that involves leveraging their own data. And I think the combination of a lake and federation, when federation makes sense, gives them a lot of optionality, a lot of flexibility as they're developing these models. So that's where we are today. I think there's an interesting future, though, and this goes back to, again, something you said about transactions in the lake and data landing back in the lake, where I think vectors could live in the lake. And that's a potentially interesting future. I think the lake is going to play an increasingly central role, largely because, again, of its openness and its cost benefits. And I think that's going to really drive its popularity across a wide array of workloads.
Yeah, I think it's a complicated and evolving subject area here. I think what you said about customers leveraging their own data for AI workloads is absolutely right. I think that's going to be an important frontier. We're trying to do that at Fivetran right now. We're trying to build basically a knowledge-based bot. Fivetran, if you're a customer support person or a sales engineer at Fivetran, you have to deal with an unusually broad array of arcane minutia about all these different systems that we connect to. Everything from the memory fragmentation implications of the lob type of SAP HANA to which Salesforce tables don't follow the change data capture rules that Salesforce documents. Those are both real examples, and there are thousands like that. So we think we're a really good use case for a knowledge-based bot, and we're working on it. It's a work in progress. Sometimes people seem to have the idea that if you're going to do AI workloads, that AI workload needs to run on a data lake and not on a traditional data warehouse. I think AI workloads can run very well on a data lake, but they also can run very well on a traditional data warehouse. It is just fine to run select star from table in your regular old data warehouse and feed that into your AI pipeline. There's nothing wrong with that. There's no data lake police who are going to come and arrest you. And AI workloads are so compute bound that the efficiency of that first step does not matter. You do not need to worry about whether you are spending too many CPU cycles at that stage, because you are going to spend many, many more at the subsequent stages. So I think it's a very promising area. It's going to drive a lot of change in the data stack. But I also think the data stack you have today is a great data stack for your AI project. I think it's a mistake to think that we have to rebuild everything just because we're feeding ultimately a text column into a language model rather than a float column into a BI tool. I think a lot of the data infrastructure that we've built over the last 10 years is going to be totally reusable for these new workloads. Do you agree?
I do.
All right. Well, very nice talking with you, Justin. Thanks for joining me, and I'm looking forward to working more together now that our systems can talk to each other through the magic of Iceberg.
Likewise. Thanks, George. Looking forward to it.